All right, I'm so excited to kick this off. All right, money, cryptography, mathematics, words you don't usually hear together, but tonight, one night only, they will all come together in this story for you. So this begins a long, long, long time ago in 2010, in a place far, far away, San Jose. So I'm an engineer, I'm also a mathematician, and I worked at Almaden Research Center, and I built some really cool systems, and I wrote a lot of papers that had complex mathematics in them. But one of the cool things was I had the office down the hall from this man. I wanted to do a better picture, but they're all copyrighted. He's one of the best mathematicians and computer theorists in the world, and he really does have that chalkboard. And I'd hang out in his office, and we'd dive into some math, and we'd do these cool proofs. But next to his chalkboard, there were all these checks, and there were $100 bills, and they were all made out to Ron Fagan. And they all said, if P is proven to not equal NP by 2013, you can cash this check. And they had built up, and they had built up. And so what's this P equals NP business? So this is one of the hardest problems in computer science. So if you think about it, if I ask you, what's 3 times 7? 21, boom. Computers are good at that too. If I ask you, what 2 numbers multiplied together come up with 42? You're like, oh yeah, 6 times 7. So that's a harder problem, and that's NP. So the easy problems are P, the hard problems are NP. And we don't know if these easy problems are the same set as these hard problems. So this has huge implications. The world as we know it could possibly be the matrix if P is equal to NP. But it's largely assumed that they are different sets, and that cryptography as we know it, which depends on these 2 things not being equal, we think that they generally aren't. So, of course, this is a big problem because Homer Simpson, in an episode of The Simpsons several years ago, goes into an alternate universe where P is equal to NP. So there's a clue that they must not be equal if Homer thinks they're not. But this isn't just a fun mathematical exercise. There's $1 million on the line if someone proves this. And so it's important to say, though, that this problem has been around for a long time. It's been around since 1971. And apparently this is what people were doing in 1971. And so for 3 decades, everyone has been trying to solve this. And if you're an engineer, you often think of this problem, but it's important to note that some of these problems take really long time to be solved. So all that changed on August 6, 2010, when a proof came out from HP Labs that P does not equal NP. So the world exploded. This guy posted this proof on his blog. It's 100 pages long. It also ended up on Scribd, and then something happened. So Slashdot caught a hold of it, which is an aggregation service, and nerds all over the globe were like, oh my God, it's finally true. Like, we're all praying. P is not equal to NP. The world is as we think it is. So I know Ron got a copy of the paper, Ron from earlier, and so I'm pacing around Ron's office being like, Ron, have you read the paper? And I open the door, and he's like eating this sandwich, not this sandwich, but a very similar looking sandwich. And Ron's like, Julia, I haven't read the paper because I'm eating my sandwich. And he's like, things like this take time. Some of these proofs take 100 years to be proven or disproven. And I'm like, Ron, Twitter does not have 100 years. And so, well, did he prove it? So, yes and no. So after all of the scientists debriefed and they all started looking at this paper, it was generally assumed that he did not prove it, but he still thinks he did, and then suddenly TechCrunch starts getting interested in mathematical problems, something that is, and real news, things that had never happened before. And all of these theorists are like, yeah, these problems are really hard, but we didn't think anybody really cared. And so what really happened on that day, August 6, 2010, was not that the world as we know it changed or didn't change. It was that suddenly people like John Markoff at the New York Times, our eyes were open to all these really interesting problems in math and computer science that we didn't even know existed anymore and had potential financial gain. So remember, folks, there are rarely new problems in the world. What you're reading is mostly just old problems that people have rediscovered. And so math and science are really, really cool. And I encourage you, you can still go out and read that proof. Again, it's 100 pages, but you too could be a millionaire. Thank you.